right, so in this particular section, we're talking about radicals that simplify completely underneath the radicand. So what I'm looking with this, and just this is something for us to look at. We talked about perfect squares before. This happens to be 64. If I square 64, I know that's equal to 4,096. So the first thing I want to do is rewrite this radical as 64 squared. X to the 8th, y to the 4th. This is understood to be to the square root. In the same way that we were talking about before, I know that the square root of 4 is equal to 2. And the reason I know that is because this is saying this is 2 squared. The square root undoes the process of squaring an option. What you're really thinking about doing here is what you're doing is you are dividing by the exponents of what you have underneath the radicand. So all of this is just going to equal 64 for the number. So what you're doing here with these variables and exponents, you're dividing. How many times does the index of 2 divide into 8? And that divides into it 4 times. So that tells me x to the 4th power, or half of the exponent, can come out. And do the same thing with the y. The exponent of the 2 divides into 4 2 times, so then I am left with y squared. And that would be your final answer for this first question, this next question 3. And just put it in just like that. And again, to type your answers in to the exponents here, this would be 64x. I use the up button to type in the 4, and then y raised to the 2nd power. Now, if you'll notice as I'm looking at question 4 here, it's a little bit different because the index of the radicand changes. So now I have the cubed root of x to the 6th, y to the 9th, z to the 15th. And again, all I'm doing here is I'm dividing the exponents. I'm asking myself, how many times does the index on the outside divide evenly into the index of the exponent? So when I do that, what I have, 3 divided by 6, leaves me with an exponent of x squared. And then 3 divided by 9 leaves me with 3. So that becomes y to the 3rd power. And the last one, 3 goes into 15. That happens 5 times. So a z to the 5th comes out. Now you might be asking, well, what happens if it doesn't go evenly? And that's coming up next when we talk about fractional exponents. So you can see again it's x squared, y to the 3rd, z to the 5th. And to type that in, we're using the different pieces. First you type in x raised to the 2nd power, then y, whoops, make sure you hit the right arrow to get the next piece. So this would be y again raised to the 3rd, and then arrow over to type in the next variable, so that it would be z to the up to the 5th. All right. Now question 5 is very interesting. Question 5 has something inside the parentheses underneath that radicand. So this is x plus 1, all quantity raised to the 8th power. So what we're doing with this is we're treating everything on the inside as one term. So all we're looking at here is we are taking and dividing that 4 of my index into the 8. That's the exponent. 4 divided by 8 is 2. So you are left with x plus 1 raised to the second power. So again, make sure you put this in. Oops, okay, so there we go. So I want my parentheses first. Inside my parentheses, I type x plus 1, and then I arrow over, raise it to the second power, and that's going to be our last answer. All right, so there's a little bit difference with this, with question 6. With question 6, what you have here is you have a number already on the outside. We've talked a little bit about this briefly, but what happens here is this is being multiplied times everything that is underneath the radical. I go back and I think, well, I know that 2 squared is equal to 4, 3 squared is equal to 9. So I think 9 is a good perfect number to start with to break this down. 18 divided by 9 is equal to 2. So I rewrite this as 5 times the square root of 9 times 2, and again 9 times 2 is 18, and I know for sure that the square root of 9 comes out. Now what you do here is you must remember that this is all being multiplied, so that's times your 3. So your final answer here will be 15 square root of 2.